Okay, so I've created the Cartesian point class, and what I want to do now is I'm back in my program class in the main method, and I want to I want to write an application that utilizes Cartesian points. Now, before I actually go ahead and do that, it might be useful to sort of review the Cartesian point class, get a kind of a summary of it. So what I'm going to do is I'm going to use a tool that's available to me in Visual Studio to create a class diagram. So I don't have to actually go through the code and sort of piece it together. I can get a kind of a summary at a high level visually. So we'll go through the steps of doing that. So I've just made Solution Explorer a little wider for us here. I have two options. I can right click on the actual project to view the class diagram, which would include all of the classes in this particular project, or I can go to the Cartesian point.cs file, right click on it and choose view class diagram. That would show me just the Cartesian point, just basically what's in the source code file. If there were multiple classes, I suppose in that source code file, it would show them both. But any rate, I'm going to do it at the project level. So I'm going to see both the Cartesian point as well as the program class. So again, right click, view class diagram, and it creates this thing. I probably want to give it a more meaningful name, but this is what I'm looking at. So I'll shrink that back up. I'll make this a little bit wider. I've got the two classes. The program class, if I expand it a bit here, has one method called main, and the Cartesian point class has three fields, three properties, a constructor, and three other methods. Okay, so we can see in that this one is a static method. I can also see in the class details here some other information, like for example with the methods I can see what type the method is, what the modifiers are, and any of the documentation I put in the summary tags are also shown here as well. Same thing, I put the summary tags on the actual fields. Um, you can utilize the class diagram to actually add new properties, add new fields, even add new methods, which is kind of interesting. So it's a more visual way, I suppose, of building your class. So I'm going to save that. I don't like the name of it, so I'm going to say, actually, you know what? I'm fine with it the way it is. I'll just save it as it is. Um, so that's class diagram. So that might be useful just to remember or to get a summary of your class. So I'm back to program again, and I want to. That's not program. This is program. So what I want to do is I want to actually create some Cartesian points. So let's do that now. Now I know that the Cartesian point class can throw some exceptions, so it's going to be prudent in my main here to set up a try-catch block. So I'll keep it pretty basic. I'll just have a try block where we'll do some stuff, and I will have a catch just to catch a generic exception. The exception that I catch, I'm calling it E, and then I'm just simply showing the user what the type of exception was and what the message associated with it is. Okay, so pretty much as basic exception handling as I could create. Now, in terms of utilizing the Cartesian point class, first off, before I create any objects, I'm going to set a limit for all Cartesian point objects. So the name of the class, dot, instead of colon, limit, which is that static property, and I've just decided to make it equal to 99 to be different. If I didn't actually do this line of code, limit would be set to 100 as it is defaulted to in the class. Next, I'll create two Cartesian point objects. Okay, so no, that's not right. That's better. So the first Cartesian point object I'm going to create is called the point. Notice the syntax for creating objects is a little bit different in C# than it is in C++. Objects are actually reference types, and when we create them, we use the keyword new, and we explicitly call the constructor typically. Okay. If I just put a semicolon here, right after the point, that would mean not that the point is an actual object, but rather a reference to an object. So a little bit of a difference there. In this case, I'm using the default arguments for Cartesian point, which I believe were 0, 0, if I recall. And then I'm creating another point called another point, which is an x value of 3 and a y value of 4. What I want to do is I want to output perhaps the distance between those 2 points. So console.writeLine, I probably should do the processing as a separate step, but I didn't in this case. The distance between the point, which is going to implicitly call the toString method, and another point, again implicitly calling the toString method, is, and then to format it in fixed decimal place format to 2 decimal places is the point minus another point. So that's calling the overloaded subtraction operator to determine the distance. So I'm just going to run that so far, and that'll test out a few things. Certainly not everything that we've put into the class, but let's run that. Oops, what I forgot to do there is to stop the program so I can see the output. So let's add that code in. Okay, so at the end of my program, I've just write line, a blank line, press any key, and in a read key. So we'll try this one more time. There we go. So the distance between 0, 0, so I can see my default constructor appears to have worked, and 3, 4, my parameterized constructor seems to have worked, is 5.0, and my distance seems to be working as well, at least with those numbers. Okay, so kind of success so far. Let's do a few other things. So I've taken the point and I want to set the x and the y value explicitly to 99. So I've done that. Notice that I don't need to use, for properties here, I don't need to use round brackets. It's not a method, it's a property. Okay, so this is the value that my x is ultimately going to be set to as long as it's in range. So that's one way of handling setting x and y in this class. Another way was we had a method called setPoint. So I've taken another point and using it to set x to 99 and y to 100. And then maybe what I'll do is similar to before, is I'll just output the distance between the points after making those revisions. All right. So the people with the keen eyes may have noticed that there's a little bit of a problem with this code. Let's see if we can see what it is when we try to run it. So the initial output seems to have worked, but all of a sudden I've got a system argument out of range exception. And in particular, the y value must be assigned a value between plus or minus 99. The parameter name was y, the actual value was 100. Let's go look at the code, and I'm realizing that exception is being thrown when I try to set y to 100 because the limit is 99. Okay, so obviously that's not going to work. So I'm going to make it 98, and we're going to try running that again. And we can see that the exception was not thrown this time. Okay. So that covers the basics of my class. I could do a few more things here to test it out a little bit more extensively, but I've hit the highlights. What I'd like to do next is I'd like to add some user input into this program where I'm actually asking the user to set the x and the y. Now in our previous courses, what we did is we created a library of useful functions to deal with validated console input and output. So I'd like to replicate that functionality in this course. So the next video will go into creating a class library that we can use for a reusable class library we can use for that purpose. Thank you.